y is equal to 0. And we need to know that parametric equations are basically just equations in terms of t. So press pause, have a go at working out the answer, and then press play when you're ready to hear the answer. Well done guys, hopefully you've managed to get an answer. So to start with, we know it passes through the point 0, 0, which means that x is equal to 0. So if I substitute x is equal to 0 into this equation here, I get 0 is equal to 2t over 1 plus t. If I multiply up by 1 plus t, 0 times anything is always 0, so the numerator on the right-hand side is just equal to 0. To find t, I'm going to divide by 2, so t is just going to be equal to 0. Now, if I do exactly the same for y, and these t values come out to be the same, then we have shown that it passes through the origin. So, if y is equal to 0, here's my equation for y. 0 is going to equal t squared over 1 plus t. Again, I'm going to multiply both sides by 1 plus t, and 0 multiplied by anything is always 0. So t squared is going to equal 0. From here, I'm going to square root my 0, which is just going to be 0. So I've got exactly the same t value again. So to get the mark in the exam, you need to say that the t values are exactly the same, which means that the curve passes through the point 0, 0. So that's how we answer the first part of this question, showing that it passes through the origin. This sentence at the bottom stating what you have found is really important that you include that in the exam to get the full marks for the question. On the second part of this question, we're going to look at the keywords which are to find the y-coordinates when x is equal to 1. So we've got some parametric equations exactly the same as what we had before, and we now know that x is equal to 1. So if x is equal to 1, you can substitute that into this equation here, rearrange to find t, substitute that into here, and that will give you the y-coordinate. Press pause, have a go at working it out, and then press play when you've got an answer. Well done guys, hopefully you've managed to come up with an answer. So, as I said, x is equal to 1, so 1 is going to equal this equation here for x. So 1 is going to equal 2t over 1 plus t. I'm going to multiply both sides by 1 plus t, so 1 times by 1 plus t is just going to be 1 plus t, is going to equal to 2t. Subtracting t from both sides leave me with t is equal to 1. So I now know that t is equal to 1, so I'm going to substitute that t value into my y equation. So we've got to find y when t is equal to 1. So y is going to equal to 1 squared, because it is t squared, divided by 1 plus t, where t is equal to 1. 1 squared is just 1, 1 plus 1 is 2, so y is equal to 1/2, and that will get you a mark in the exam. Part B of this question says show that the area enclosed by the curve, the x-axis and the line x equals 1 is given by the integral between 1 and 0 of 2t squared all divided by 1 plus t cubed dt. Now the key formula you're going to need to know to be able to answer this question is that you need to know the quotient rule which is given in your formula book. Now the quotient rule says if you've got a function x is equal to u divided by v, then dx by dv is going to equal the all over the bottom squared, so v squared is in your denominator, then it's the bottom, which is v, times by the differential of the top, which is du by dt, minus the top, which is u, times by the differential of the bottom, which is dv by dt. So we say it's all over bottom squared, bot times the differential of the top, minus top times the differential of the bottom. And this is given in your formula book, so you need to make sure you know how to use it and how it's written and which form it's written in your formula book. We're then going to be integrating parametrically. So if I've got to integrate y with respect to x, this is normally how we integrate on the left-hand side. So we're finding an area, so we know when we're looking at an area, we're looking at integration here, especially when it's a show that question with an integral sign at the front. But this is just in terms of normal x and y, and we've got to do it parametrically in terms of a third variable. So what I can do is I can replace my dx with a dx divided by dt all times by dt, because basically like these t's can cancel out, leave me with y dx. So y dx by dt times by dt is the same as the integral of y dx. And you need to be able to know these two forms. So it's basically like these dt's cancel, leaving you with exactly the same values. From here, we're then going to have a go at answering the question. So see if you can use these two facts, press pause, and then have a go at working out the answer and press play when you're ready to hear the answer. Well done, guys. So first of all, we're going to look at differentiating our x function. So x is 2t over 1 plus t squared, and in this equation here, I've got dx by dt, so I've got to work out the value of dx by dt. Now, because I've got two things divided by each other, that means I'm going to be using the quotient rule. So I said it's all over the bottom squared. Now, the bottom is 1 plus t, so it's all over 1 plus t squared. Then it's the bottom, which is 1 plus t, times by the differential of the top. Now, the differential of 2t is just 2, so that's the differential of the top, minus the top, which is 2t, times by the differential of the bottom, and the differential of 1 plus t is just 1. So this is using the quotient rule. From here, I'm just going to expand the numerator and tidy it up. So expanding 1 times 2 gives me 2. T times 2 gives me 2t. Then I've got a 2t take away a 2t, which is just going to leave me with 2 over 1 plus t all squared. So that is the value of dx by dt. So we know what y is. Y is this expression here, t squared over 1 plus t. We've worked out dx by dt, which is this expression here, and dt will just remain as dt. So we're going to substitute all these values in. So instead of writing y, I've written t squared over 1 plus t, because that is the value of y. Instead of writing dx by dt, I'm going to write 2 over 1 plus t all squared, because that's the value of dx by dt, and dt just stays the same on the end. From here, I'm just going to tidy up. So 2 times by the t squared is just 2t squared, which is what my numerator is. And my denominator is 1 plus t times by 1 plus t all squared, which will give me the 1 plus t all cubed. Therefore, we have shown how to answer this question, and we've shown that the area between the curve, the x-axis, and the line x equals 1 is given by this formula. Make sure if it is a show that question, you have said, therefore you have shown the question. Don't just leave it and not say what you have found. Make sure you have made it obvious to the examiner that you know what you were trying to work out and what you found. The last part of this question is a hence question, which means we're going to be using the answer we've just worked out. So we've got hence, find the appropriate substitution to find the exact area enclosed. So to be able to do this, we need to know key facts. And our key facts we need to know is to be able to integrate using substitution. Now, to integrate using substitution, we need to make sure we know what our substitution is. Generally in the exam at A level, you are told what the substitution is. In this question here, we are not told the substitution. So the substitution you're going to choose is what is in the brackets. So in this case here, u will equal 1 plus t. From here, you then need to differentiate this function to find the value du by dt, and you need to rearrange it to find dt. Once you've done that, you need to take your u expression and rearrange that to find t. You're then going to change the limits. So instead of being t values, you're going to convert these to be u values. And then you're going to substitute all these things that you've just worked out. So these last 3 bullet points here that you've just worked out, you're going to substitute the values into this expression so it is all in terms of u. Once it is all in terms of u, you will then be able to integrate and work out the answer. Press pause, have a go at working out the answer, and then press play when you're ready to hear. So from here, okay, we should have let u is equal to 1 plus t. So well done if you managed to get u is equal to 1 plus t. Great start. We're now going to differentiate. So the differential of u is du by dt. Differential of 1 is just 0, and the differential of t is going to be 1. So du by dt is equal to 1. From here, I need to find dt. So I'm going to multiply both sides by dt. I can multiply it like I can fractions. So du is equal to dt. So you can see this expression here on the end, dt, I'm going to replace with du. I then need to rearrange this to find the value of t. So getting rid of this plus 1 from both sides, t is going to equal to u minus 1. So you can see in my numerator I've got a t, so I'm going to replace that with u minus 1. Instead of writing dt, I'm going to write du. And my denominator, I've got 1 plus t, which is the same as u. So all these terms here on the right-hand side, I can convert in terms of u. So the last thing to do is this next step here, which says change the limits. So I'm going to change my limits to be in terms of u. So to start with, I'm going to look at this top limit when t is equal to 1. Now, if t is equal to 1, u is equal to 1 plus t. So 1 plus t, where t is equal to 1, 1 plus 1 is 2. So my new top limit is going to be 2. I can do the same when t is equal to 0. So if t is equal to 0, u is going to be 1 plus 0, and 1 plus 0 is going to be 1. So I'm going to be integrating between 2 and 1. So all I need to do is change my limits to be 2 and 1. I've got two lots of my value of t, and we knew t is u minus 1 all squared. And then that's going to be divided by my 1 plus t, which is u cubed. And I'm just replacing the dt with a du on the end. So everything now is all in terms of u. From this stage here, I'm going to look at each term and I'm going to expand the numerator. So I've got u minus 1 squared. Remember, this means u minus 1 times by u minus 1. So I'm expanding two brackets. So u times u gives me the u squared. Then I've got a u times by a minus 1, which is going to be a minus u. Then I've got to do the same again, which will also give me a minus u. And then I've got a minus 1 times a minus 1, which will give me a plus 1. So expanding the numerator gives me two lots of u squared minus 2u plus 1. From here, I'm now going to multiply everything in the numerator by 2. So 2 times u squared is 2u squared. 2 times minus 2u is minus 4u. And 2 times plus 1 is 2. From here, I'm going to separate these out into three separate fractions. So I'm going to take the 2u squared divided by u cubed as one term. Then I've got minus 4u over u cubed is my second term. And I've got 2 over u cubed, which is my third term. Now, because I've separated them out into three separate terms, it is easier to integrate. But before I can do that, I'm just going to tidy up the terms. So I've got u squared divided by u cubed. So if I can cancel the powers, so the squared and the cube cancel, leaving me with just a 2 over u. Or I can subtract the powers. So I've got u to the 2, take away 3, which will be u to the minus 1, which is the same as 1 over u. Or in this case, 2 over u. From here again, I've got 4u divided by u cubed. So cancel a u out on the numerator and a u in the denominator. So that is 4 over u squared. Bring it up to be a power in the numerator. So I could do 1 take away 3, which will give me minus 2. So that is the same as minus 4u to the minus 2. So you can see these are the first two terms I've got written down here. So I've got 2 over u for the first term, minus 4u to the minus 2 for the second term. And then the last one is nice and easy to write as a power of negatives, gives you 2u to the minus 3. From here, I just need to integrate each of these terms. Now, the reason I've written this as 2 over u is because you should know that the integral of 1 over u is ln of u. So this is just 2 ln u. These last two, I'm just going to add 1 to the power and divide by the new power. So I've got 2 ln u for the first one. Add 1 to minus 2 gives you minus 1. Divide by the new power is divide by minus 1. And you've got a minus and a minus, so these will become a positive in a minute. From here, I've got 2u to the minus 3. Add 1 to the power gives you minus 2. Divide by the new power is minus 2. So I can simplify this. So I've got minus times a minus is a plus. So this means 4 over u. And this one here, the 2's are going to cancel. The plus and the minus is going to be a minus. And I've got u to the minus 2, which is the same as 1 over u squared. So these two minuses have become a plus. The plus and the minus has become a minus. The u to the minus 1 is the same as 4 over u. And u to the minus 2 is the same as 1 over u squared. From here, I'm now going to substitute in my limits. So I'm going to substitute in 2. Then I'm going to take away when I've got 1 substituted in. So I'm going to replace all the u's with 2 first. And then I'm going to replace all the u's with 1. Once I've got those two values, those values need to be subtracted from each other. From here, I've got 2 ln 2, which I'm just going to leave as 2 ln 2 because we need to give our answer in exact form. 4 divided by 2 is just 2. minus 1 over 2 squared, which is going to be minus a quarter, minus 2 ln1. You should know that ln1 is always 0, so this first term is 0. 4 divided by 1 is just 4, and minus 1 divided by 1 squared is just going to be 1. So I can simplify that down. Note I've worked out each term separately before I've combined them together. Just make sure you read the question carefully, because this one said show detailed reasoning, so make sure you show all you're working out. If it doesn't say show detailed reasoning, then you don't need to put so many steps in, but just read the question carefully, and the more steps you show, the easier it is to get the marks in the exam. So from here, I just need to collect the terms. So I've got 2, take away a quarter, and then in the brackets, I've got 4 minus 1, which is 3, times by minus 1 is going to be negative 3, which will give me 2 take away 3 is negative 1, take away a quarter, which will give me minus 5 over 4, and give yourself a big tick if you've got that correct. So please make sure you show you're working out. From this stage here, you could type this into your calculator to check that you have got the right answer, because your calculator will do any sum for you. So make sure that you do check your answer on the calculator to check you have got the correct answer. The only thing is the calculator will give you a decimal answer rather than an exact form. But you can work out this as a decimal, and you can check that the two values you get at the end are exactly the same, so you know that you are correct in the exam. If you found this video useful, please share, like and subscribe so we can all get great at maths.